Hello friends, welcome to my channel. Here I solve LeetCode problems and prepare to the code interview. Today's problem number is 1814. Count nice pairs in an array. You are given an array nums that consist of non-negative integers. Let us define function ref of x as the reverse of the non-negative integer x. For example, ref of 1 to 3 equals to 3 to 1, and the ref of 1 to 0 equals to 1. A pair of indices e and j is nice if it satisfies all of the following conditions: e greater or equal to 0, j greater than I, and less than length of nums, and the sum of nums of I plus ref of nums of j equals to nums of j plus ref of nums of I. Return the number of nice pairs of indices. Since that number can be too large, return it modular 10 power 9 plus 7. Let's solve it straightforward. First of all, we need to get a dictionary of ref numbers. So let's create a dictionary refs. It's empty dictionary for each num in nums. I will calculate each ref number straightforward. So to do it, ref equals to I will convert each number to a string. To do it, I use function stir of num and reverse it. After, I convert back to int. So I have a ref number, and I need to add it to the dictionary. Refs of num equal to ref. I need to define result and return it. Return result model to this number. And the last thing, I need to collect all pairs which satisfied condition. To do it, I used two nested loops for I in range 0 to length of nums -1, and internal loop for j in range I plus 1 to length of nums. And check the condition for each pair. Nums I plus refs of nums j equals to nums j plus refs of nums I. And for So the pairs increment results. Result plus equal 1. It should work. Let's check the tests. Yes, test passed, but I think it could exceed the time limit because the time complexity of this algorithm is odd and square, and it could be too slow. Let's try to submit it. Yeah, time limit exceeded. Let's use this test case. We need some better solution. Let's check the main condition. We, we can change it and calculate it faster. So how we can change it? We can move parts of this expression and keep same indices uh, on the different parts. So now you can see that we need to have some expression depends on one indices. So we need to calculate difference between num and ref of nums, and to get number of pairs that have the same differences. So I think we can get final result in linear time. Let's do it. Delete all solution, and for this solution we need to change definition of refs variable, and in this case I defined dictionary as default dict of int. It needed to easily increment values even if we don't have values in the dictionary. And now for each num we we, we will get difference num minus ref, and increment each with value. Now we have count of differences in refs, and we need to count total number of combinations of pairs. So and also we don't need the exact amount of difference, we need only counts. So for v in refs dot values, so we need only values in of dictionary refs, and also we need only v greater than 1. So because if we have only one differences, it means that only one indices in nums have has this difference. So we need at least two indices with the same differences. And for z greater than 1, we need to count number of combinations and add it to result. To get number of combination, we have a formula of number of combination of two elements from some set of elements. And the formula is z multiply to v minus 1 divided to 2. That's all solution. Let's run tests. Some small error. Test passed. Let's submit it. It works. It's pretty efficient. And now this algorithm has time complexity of n, so it's linear and quite effective. Also, it has a memory complexity O of n because I created a refs variable which depends on the length of nums. That's it for today. Thanks for watching. See you tomorrow. Bye.